Hello everyone. This video lecture covers learning objectives 3 and 4. And we're going to focus on 4 methods that we can apply to study cost behavior. So first I'm going to take a look at what are the 4 methods that we plan to cover in this chapter 6. So 4 methods to analyze cost behavior. I'm going to basically tell you that there are 4 methods, but we can also divide these 4 methods into 2 categories. The first 2 methods, account analysis and scatter plots, are more qualitative and graphical methods. So they are quite different and they don't use a lot of quantitative analysis or maybe equations or mathematical calculations. The last 2 methods, high-low method and the regression analysis, actually are very quantitative. So we're going to look at all these 4 methods, give you different perspectives. The first method is called account analysis, and this method is very subjective. So normally you need to have a lot of experiences and have a very deep understanding of your company, business operations, and also industry. So very likely you have to use your personal judgment with your experiences to classify each general ledger account as variable, fixed, or mixed. So I'm not going to spend too much time because all these experience judgments actually you want to have them, you have to really spend enough time and learn every industry in details. So there are not many really exercises I can give you even. So just keep one thing in mind, account analysis is one of them. And the second one is the scatter plots. The scatter plots is a graphical method. So typically we collect the data and we use a historical data to determine a cost behavior. And normally you have a 2-dimensional graph, and one is you have 2 major axes. So one is the x-axis, normally the volume data, and also you may have a vertical line, which is a y-axis. That's for the historical cost data. So typically you're going to have volume data associated with the cost data. So you have a pair of 2 numbers. That's actually your data point. Then you have a collection of them, you have a set of them. You can always plot y values, which is the cost data, against the volume data, the x value, to find a lot of dots in the graph, and we call that scatter plots. And this can help managers visualize how strong relationship is between the cost and the volume. So you can have a very good idea that, okay, do I have a fixed cost or variable cost or mixed? So the next example actually is exactly the application of scatter plots. So this is about the relationship between utilities cost and the number of guests. So horizontally we have a volume, which is the number of guests, and vertically we have a y-axis, which is the utilities cost. So if you look at those plots, to me, I consider this is a variable cost. The utility cost is a variable cost. It's not a fixed, it's not a mixed. It's a very, very like a variable cost, because it seems to me I can basically see a straight line pathing, starting from the origin and pathing to these points with the whatever variable cost per unit. So this can actually help me to say, well, my conclusion is utilities cost should be a variable cost. So I just finished these 2 qualitative and graphical methods. Now let's take a look at one of the quantitative methods I just mentioned, the high-low method. So what is a high-low method? So it's pretty simple from certain perspectives. So basically we can take a look at 3 steps. Well, in order to apply the high-low method, well, we are going to basically first find the variable cost per unit, which is kind of slope of the cost line. I think I have introduced cost line in the prior learning objectives. You probably know what I mean. So basically the cost line is a straight line, and that's kind of a cost equation we can use to study the cost according to whatever volume data. The next one is you can use that to find a fixed cost, which will give you vertical intercept. The last one is you can create the cost equation. The advantage is it's pretty easy to use this method. The disadvantage is we only focus on 2 data points. So that's actually probably give you the idea why we call this high-low method, because these two data points are essentially the highest activity and the lowest activities we're looking at. Okay, we're looking at. So that's sort of thing we are focusing on. So I would like to actually use the next exercise to give you a very nice idea how we can apply the high-low method to study the cost behavior. So this is a question we're looking at. So this particular factory is going to use a high-low method to determine flour power's cost equation for van operating costs. And then once you have the cost equation, you want to predict the van operating cost at a volume of 16,000 miles. And this person, which is a lady Carol, she's owner of Flour Power, operates a local chain of floral shops, and each shop has its own delivery van. Instead of charging a flat delivery fee, the WU wants to set the delivery fee based on the distance driven to deliver the flowers. WU wants to separate the fixed and variable portion of her van operating cost so that she has a better idea how delivery distance affects this cost. She has the following data from the past 7 months. So this is what do we have here, and the month is from January to July. So there are 7 months, and every month has different mileages and also the operating van operating costs. So we're going to apply the high-low method to find the cost equation based on the data we have. Then next, we can always use that equation to make a prediction about the van operating cost. So let's come to this first step. We need to find the slope of the mixed cost line. So how to find a slope? So in mathematics, I guess you probably have heard of the rise over run. So we have to know what's the difference in y, which is cost, and what's the difference in volume, that's x, okay, the x. Then this slope represents the variable cost per unit of activity. So therefore, we have to go back to the data to look at, okay, so what is the highest activity and what is the lowest activity? So this miles driven actually tells you these numbers. So if I look at the miles driven, because miles driven, that's volume, that's activity. So I would say the February 17,500 gives me the highest activity. Then for the lowest activity, I'm looking at July, which is 14,500. So therefore, I would definitely just write down these two numbers then for me to use. So I will have 17,500. Then the operating cost is about 5,700. Then for the July, I'm looking at 14,500, and the cost is about 4,920. So when I come to step 1, what I can do is I can definitely put the highest activity. I'm looking at February, and the data is 17,500. Okay, then the cost is 5,700. Okay, that's highest activity. Then if I look at the lowest activity, I'm looking at actually July. The lowest activity is 14,500. Then the cost is about 4,920. Okay. So therefore, the slope, which is essentially the variable cost per unit, is nothing but the difference in cost divided by difference in volume. So I'm going to use the 5,700 minus 4,920, the quantity divided by 17,500 minus 14,500. Okay. Then I'm going to compute the result of the numerator and as well as the denominator so that I can finish my division in the next. So let me get my calculator in front of us. So the next I'm going to have 5,700 minus 4,920. I get 780 here. Then divided by the denominator, which is 17,500 minus 14,500, I get 3,000. Okay. So the result is 780 divided by 3,100, which is $26 per mile. Okay, so that's what I need from step 1. So next, we are going to find the vertical intercept. So the vertical intercept is basically, if you look at the cost equation, which is y equals ax plus b, right? And this is the cost equation. And from step 1, we know that the slope a is 0.26 already. So therefore, I can have equation y, which is 0.26x plus b. Okay, and this b is basically the vertical intercept I'm looking at, which is actually the fixed cost. So how to find the b? If you know those data points, actually you can easily find the b. So all you have to do is there are highest activity and the lowest activity data, right? Remember what we have here. So you can grab either highest activity or lowest activity data point to solve for b. For example, I'm going to pick this highest activity. I'm going to use highest activity data point to solve for b. So I'm going to copy them here. And I have a 17,500 and 5,700. I'm going to apply these numbers to solve for b. So how to do that? You have to solve a mathematical equation. It's a linear equation, only one variable. It's very simple. So what I'm going to do is I will set up an equation. So y is 5,700 and equals 0.26 times x, which is 17,500, then plus b. You can see that all you have to do is solve for b. So step-by-step work is I have 5,700 equals, I'm going to multiply 17,500 by 0.26. I get 4,550, then plus b. Not just from this equation, you know how to solve for b, right? All you have to do is do one-step subtraction, so you can find the b in this way. So just use 5,700 to subtract 4,550. So b actually is 5,700 minus 4,550. So the result is 1,150. Alright, so finally, you really have your cost equation set up in this way. Y equals 0.26x, then plus b, which is 1,150. So x is miles, and y, that's the dollar of the cost, which is that's dollar, right? The cost. So now we can actually use this to that's a conclusion of C. So this equation is set up. Okay, it's set up. So y equals 0.26x, then plus 1,150. So the prediction is what is the prediction of cost, value operating cost at 16,000 miles? Okay, so basically we are going to apply this equation to do some prediction and forecast, right? So pretty simple. All you have to do is plug in 16,000 for x. So we multiply 0.26 by 16,000, then add that quantity to 1,150. Okay. So the result is let me do that. It's 0.26 times 16,000. I get 4,160, then plus 1,150. I get 5,310. So I get 5,310. Okay, dollars. So sorry, and so therefore my prediction would be, well, I have a 5,310 cost. That's a prediction if the van has 16,000 miles, okay, in the next month's operation. Alright, so that's about the high-low method. So next, I want to talk about how to use a regression analysis to analyze cost behavior. So you probably have heard of regression analysis in many math or maybe some introductory business analytics classes. I'm not going to mention too much, but the whole idea is the regression analysis is I give you a lot of data collections. Then you try to use a linear equation. Typical linear equation can be as more complicated, but typically you have a linear equation. You try to find a linear equation to fit the data. So therefore, you can imagine that there are so many options of linear equations, right, with different slopes, different y-intercepts that you believe can fit your data. So which one give you the best fit? Which one give you the best fit? And the process to identify the best fit is called regression analysis. And this process is called regression. So typically, you can always use Excel to do that work. So all you have to do is use the Excel function to do the regression. To use Excel built-in mathematical tool to find the best fit for this data, and the result is going to be actually the regression analysis, and you have a suggested equation. So instead of showing you how to do regression, I'm going to just jump to the regression analysis result. So this is actually a typical regression result here. So, and all you have to pay attention to at this stage, regression analysis can be very complicated. And what I want to do is I want to tell you that, okay, in order for you, okay, to take advantage of this method at this level, let's focus on three things. Okay, so these are three things that are all in this yellow color. So that's all you have to know about regression analysis. So if we look at R square, which is sitting here, that's very important. And R square is 0.94726. It's very important. I'll tell you the reason later. And also the coefficients, the intercept, which is a fixed cost, that's very important. And x variable 1, that number coefficient is very important because that's a variable cost per unit. So all you have to focus on are these three numbers, in this particular class. So first, let me talk about R square value. I just mentioned the R square value, and I told you that it's extremely important, and why. So this R square value will tell you that the goodness of fit. So how this data, how the linear regression equation fits into the data, and how well does a line fit the data points. So ranges from 0 to 1. Sometimes you're lucky that your data is very nice. You're able to find a very, very nice straight line, a linear equation fit the data. But sometimes your data shows a curve, so linear equation may fail to fit the data. So in that case, you may not have a good R square value. So that's the sort of idea of R square value here. So the goodness of fit and ranges from 0 to 1, that's all you have to do. So typically, if you have a R squared value bigger than 0.75, then normally you would consider there is a strong correlation. Okay, so if you have a value kind of below 0.25, if R squared value is below 2.5, you have a very, very weak correlation. So anything between might be kind of a medium or mild correlation, so you can imagine that. So just give you some idea here. And next, can talk about the data concerns here, because sometimes when you have data over many years, the question is, can we really use them to get a straight line? Are they really reliable? So there are a few things. First of all, make sure that when you apply the linear regression, if it's about a business operations, make sure that those business operations are always within relevant range. And seasonal variations, this is actually something very, very common, because if you look at retailers, those are merchandisers, Macy's and dealers, or maybe JCPenney or Best Buy, these stores, normally during the holiday season you can see that the boost of the sales, not because they are doing much better in their business operation, just it's a very seasonal variation. And maybe after post holidays, maybe February or March, you can see actually the dip of their sales, which is also very common because that time people probably don't spend their money already buying gifts. So there are seasonal variations you want to look at. And sometimes we do have inflation, Some years you see a lot of inflation, some years you see less, so you have to consider that. And also outliers of normal data points. So if the company receives a special order, a huge number of special orders, that will affect the data and the sales, everything. So that may mislead you a little bit. So all these issues are very, very important considerations when it comes to data analysis. Sometimes you may have to manually change some of these data, abandon some outliers, and also get rid of some of the effects from the seasonal variations. And also sometimes you have to adjust your inflation factors. So all these things actually are part of your considerations when it comes to data analysis. Okay, so now the question is how we can actually use this data here. How can we use this analysis here? So what I can do is I can basically tell you how to derive a sort of equation based on this report. So first of all, just back to this data, I would say I'm 100% sure that this is a strong linear correlation. We can easily identify a linear equation to fit the data. Now the question becomes, how we can derive the equation. I can show you what I have here. So how to identify equation? I'm going to use the coefficients sitting here. So what I can do is I'm going to write down an equation for you by using this number. So what's happening here is the y, okay, the y, I'm going to put a cost here. The total cost actually is the slope multiplied by x, the activity, the volume data. So how to find the slope? You can read the number here. It's 7.849766. Okay. Sometimes you may not need to use that number. So sometimes question may say, well, you might want to round to the nearest cent or whatever. So let me put the 7.85 as well, just in case. Some questions may require you to have 3 decimal places or 4 decimal places for the solutions. So you can use either one of them. So then I'm going to multiply the slope by x. So x is what? Is a volume data, input. So could be whatever volume, mileage, could it be the hours, could it be the number of units, whatever. Then the plus the fixed cost, and the fixed cost is the y-intercept here, which is 14,538 and 0.5. So this is about a fixed cost. Okay, fixed cost. So once you have this very nice equation derived from the regression analysis, you can apply this equation to do the predictions forecast, because as long as you know the x volume input, you plug in the input for x, you do the multiplication here, then add the numbers, you can predict the y. So I will leave that to you. There might be some exercise for you to look at, and if you have any questions, feel free to let me know. But this is how you use the regression analysis. So first, use R value to check if there's a strong linear correlation. If not, you probably don't want to use it. If there's a strong linear correlation, there we go. So we can use the analysis result to build a linear equation. In this case, you can have the linear equation. There are 2 coefficients. The first one is called the intercept. That's your fixed cost. And the second one is your slope, the variable cost per unit. So you can pull out these 2 numbers, put them down here, and derive your equation. So that's about this video lecture, and I'm going to talk about learning objective 6 in the next video. So thank you for watching, and I will see you next time.